Hello everyone. Today let's see a presentation about induction motor drives by T. Shanmupriya 17A096. First, what is an induction motor? Let's see. An induction motor or asynchronous motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. Induction motor works on the principle of induction where electromagnetic field is induced into the rotor when rotating magnetic field of stator cuts the stationary rotor. Induction machines are by far the most common type of motor used in industry, commercial or residing settings. It's globally used in a large scale. Unlike synchronous motor, a three-phase induction motor has a high starting torque, good speed regulation, and a reasonable overload capacity. An induction motor is highly efficient with full load efficiency varying from 85 to 97 percentage. The sum of the applications of induction motor are lift cranes host. The main reason is their load carrying capacity. They are also used in trams and trains in other countries, etc. Now, the main key features of an induction motor or highlights of induction motor are they are simple and rugged in construction. Their motors are cheaper and easy to maintain due to the absence of commutator, slip ring, and brushes. They are the one of the main key points of induction motor. Now, let's see what are the methods or ways used to control the induction motor. The broadly classified two main ways to control the induction motor is scalar control and vector control. Now, what is scalar and vector control? Scalar control is the control in which the induction motor speed is controlled by the setting the voltage and frequency of the stator so that the magnetic field in the gap is maintained at a desired value. To maintain a constant magnetic field in the gap, the voltage frequency ratio must be constant at different speeds. Now, what is vector control? Vector control, also known as field oriented control FOC, is a variable frequency drive control method in which the stator currents of the three phase AC electric motor are identified as two orthogonal components that can be visualized by a vector. Now let's see the difference between scalar and vector control methods. Scalar method is simpler form of control method whereas vector is complex mathematical model. Scalar method has a good steady state performance but a poor dynamic response. Vector method has a precise control of AC motor and an excellent dynamic response. Scalar has low performance of drives with higher power dissipation, whereas vector control method has high performance drive and lower power dissipations. Now, in this slide, we are going to broadly see about what are the ways and techniques used in scalar control method. The main techniques used in scalar control method are stator voltage control with constant frequency, supply frequency control with constant voltage frequency control, pole changing, rotor resistance control, slip power recovery scheme. These are some of the techniques in scalar control method. In this PPT, we are going to see about stator voltage control with constant frequency in a broad way. Stator voltage control. A simple method of controlling speed is to vary the stator voltage at constant supply frequency. This can be achieved by using an AC voltage controller by varying the instant of firing. The stator voltage of the induction motor can be controlled. This method is being used as a solid state soft start for constant speed induction motors, where the stator voltage is applied gradually to limit the stator current. This is a graph of speed torque graph of a simple induction motor. The synchronized speed and torque equation are given below. From these equation, we can conclude that this method is easy and simple, still rarely used because a large change in the supply voltage is required for the relatively small change in the speed. Large change in supply voltage will result in large change in the flux density. Hence, this large supply voltage is not possible, and the disturbing the magnetic conduction of the motor. So this method is rarely used. Now, from the graph obtained from the induction motor, we can calculate it running. We can still calculate its speed, running speed, and various components such as starting torque, ending torque, and etc. From these equation, from these equations, we can infer that the torque is proportional to the voltage squared and current is proportional to voltage. Starting torque, running torque, and maximum torque are reduced as voltage decreases, but the slip at which the maximum torque occurs remains the same for whatever voltage. This method is suitable for applications where torque demand reduces with speed. Some applications are fan, pumps, etc. This method enables speed control below rated speed because the supply voltage cannot be increased beyond the rated value. As the voltage is decreased to decrease speed, the slip increases, hence, the efficiency of the motor is very low at low speed. As we have discussed earlier, the utmost key features or the advantages of induction motor are simple and rugged in construction. The construction mainly consists of the stator and rotor parts, and the other key features or the advantages are they are cheaper in cost due to the absence of brushes, commutators, and slipping, and they need less maintenance due to the absence of brushes, commutator, and slipping, and durability. And another major advantage of the induction motor is that its durability. This makes it the ideal machine for many users. This results the motor to run for many years with no cost and maintenance. High starting torque. The starting torque of the induction motor is very high, which makes motor useful for operations where load is applied before the starting of the motor. Three-phase induction motors will have self-starting torque unlike synchronous motor. However, single-phase induction motors does not require self-starting torque or does not have self-starting torque and are made to rotate by using some auxiliaries. Speed variation. The speed variation of the induction motor is nearly constant. The speed typically varies only a few percentage going from no load to rated load. All these advantages make the induction motor to use in many applications such as industrial, domestic and many applications. Some of the applications of the three-phase induction motors are lifts, cranes, hoists, driving lathe machine, crusher, oil extracting mills, textiles, etc. And some of the single phase induction motors applications are pumps, small fans, mixers, toys, high speed vacuum cleaners, and etc. The main disadvantages of the induction motors are a single phase induction motor, unlike a three phase induction motor, does not have a self starting tap. During light roll condition, the power factor of the motor drops to value low, very low value. Speed control of induction motor is somewhat very difficult to attain. So thank you friends. Thank you for listening my presentation. Thank you. Hope you have a good day.